Hello everyone, I'm Billy Younger and I'm here with PhysicsSolutions.com to solve a typical physics problem. This actually works in chemistry as well as physics. In fact, anytime you need a number of moles, which remember is directly proportional to the actual count of atoms, or if you're doing compounds, it's actually proportional to the count of molecules. So I have a question here and we're going to solve it. And in order to do so, I'm going to share my screen to show you my iPad. So that should come up any minute now. And what you'll see is we're considering having a sample of copper, that's pure copper, at 73.0 grams of copper. So in other words, we got like a chunk of copper, we weighed it, it evidently weighs 73.0 grams. And what we're asking now is how much or how many moles of copper is that? And like I said, a mole is a very specific number of atoms or molecules. So that this will come in handy later when I actually do a similar calculation where I ask you, for instance, the mass of a single atom of carbon. So here we have, you are given a 73.0 gram sample of pure copper. And here's the atomic weight, 63.546 grams. That's a decimal, just in case anybody misses it there. Oops, I should probably put that in black instead of blue. How many moles of copper is that? So again, this is something that you'll need, for instance, when you're doing chemistry, because atoms and molecules actually group up in integer multiples of atoms or molecules. And since the numerical number of atoms and molecules is fixed for a mole, it helps to know exactly what fraction of a mole you have. So with this in mind, I'm going to carry out the solution as follows. I'm going to take the 73.0 gram. Actually, I'm going to write that in blue to keep it consistent with my solution. I'm going to write the 73.0 grams of copper. And in order to do this, I actually could take the molecular weight, which in this case, it's an atomic weight. That's actually measured. One way of thinking about it in the periodic table is that measure is in grams per mole, in which case, if I take the mass in grams and divide it by the grams per mole, then I get the number of moles. So I'll divide this by 63.546. As always, I like to carry at least one extra sig fig on all calculations, so I prefer to use 63.55 rather than just 63.5, because that's just exactly the number of sig figs that I was given. So when I actually do this, this is going to give me a number of moles. So what I'm going to do is take 73.0 and divide it by 63.546, and what we get is 1.1, and I'll go ahead and carry an extra sig fig. That's 4.8. Actually, I should call that 4.9 moles. And as the note says, it says pay attention to each number you use in the calculation. So really what I did was I divided the mass of the sample by the atomic weight. So that's the actual numbers we have, and hopefully that's pretty straightforward. That's it. Have a good day.